All right, so let's take a look at this first example. Again, just follow along your notes. You don't have to, write down the problem again. And I believe there's also a graph attached for you, okay? All right, so we're asked to describe the transformation, how is H different from F, and then graph the function, right? Okay, so again, this is in vertex form, right? This tells me I'm shifting it 1 to the right, and this tells me I'm shifting it 2 units up, okay? So for the description, how is H different from F? You would say it's shifted 1 to the right, 2 units up. That's all you need to say, and you're done with that part. And then part B, you're just going to sketch it. And I'm going to draw some tick marks over here. Two, three, four, five. 1, 2, 3, 4, 5. Okay, so your parent function is 0, 0, right? Let me show you a quick trick. The coefficient for this right here, the a value right here is 1. If it is an integer, you can quickly do a rise up 1 over 1 to the right, up 1 over 1 to the left. Okay, so that only works if your a value is an integer. Integers are nice numbers, okay? So you can't have fractions. And you can't just continue to go up 1 over 1. Because remember, this is a parabola, it's curved, right? It's not a line, just for the first set of points. Vertex right here, right? This is in vertex form. The vertex, basically, for H, right? This vertex, we said it shifted 1 to the right and 2 units up, right? The vertex is 1, 2, right? And likewise, this a value is also an integer, right? So you can go up 1 over 1, up 1 over 1, and there is your h of x. Okay, so this is my f of x, there's my parent function, and what I just graphed right here, right, is going to be my h of x. All right, so there's problem number 7. That was relatively quick. Hopefully that made sense. Let's move on to number 8. All right, so same exact thing. My f of x is equal to x squared, and on part A, I'm given h of x is equal to negative 3x squared. All right, so again, how would I describe, how is h different from f? You would say, number 1, because a is less than 0, right, there's a reflection over the x-axis. And because the absolute value of a is greater than 1, right, it's a vertical stretch by a factor of 3. Okay, so remember in the notes I made a mistake there. So again, factor of 3. So for the vertical stretch or shrink, it's by the factor of a. For horizontal, it's factor of 1 over b. Okay, so again, in case you got confused, let me just confirm that is the correct way of stating it. All right, so let's graph it. So over here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so 0, 0, up 1 over 1, 0, 0, up 1 over 1 is my parent function. Of course, you can plot more points if you want, but there's my f of x. And this vertex right here, right, this vertex is also 0, 0. The only thing that changes, right, is I reflect it across the x-axis. Now, remember that trick that I showed you, right? If this a value, which is a negative 3, is an integer, negative 3 is an integer, you can do a rise over run. Go down 3 units, 1, 2, 3, over to the right 1. Go down 3 units, over to the left 1, just for the first set of points. Right? And this would be your h of x, right? Notice it got reflected over the x-axis, and it got stretched by a factor of 3. Vertically stretched by a factor of 3 means it gets pulled away, right, from the x-axis. So now that you know what that means. All right, now on part B, it's an interesting problem. They give you this. I know it says h of x. Maybe I'll call it, actually, I guess I'll just redraw the picture. H of x is equal to 1/4 x parentheses squared minus 2. All right, so there's actually 2 ways of describing this, okay? So let me show you way 1. This is actually your b, okay? So anything in the equation, that's your b. But how would I state this if I'm making a comparison, right? So B is 1/4. So notice the value of B, right? It's between 0 and 1, right? 1/4 is between 0 and 1. Therefore, it's a horizontal stretch by a factor, okay, this is where it's critically important, 1 over B, 1 over 1/4, okay? 1 over B. And 1 over B, right, is just, 1 divided by 1/4 is just 4, okay? So horizontal stretch by a factor of 4, right? 1 over B. Okay, horizontal stretch by a factor of 4, and then, of course, this thing right here, right, tells me I'm going to shift the graph 2 units down. Okay, so that's one way to describe it. Horizontal stretch by a factor of 4, 2 units down. Now, what's another way of describing this? Well, way 2, right, you can actually simplify this function, right? 1/4 x comma squared, 1/4 x parentheses squared, right, minus 2. You could square this, right? If you square it, you're going to get 1 over 16 x squared minus 2, right? This is the exact same function as this. And so way 2, you could have described it as a vertical, right? A vertical shrink, right? Because now this is your A value, right? By a factor of the A value itself, right? 1 over 16. And of course, it's still going to be 2 units down. So this is another way, right? Remember I said vertical shrink is the same thing as a horizontal stretch. Horizontal stretch is just a fancy way of saying, you know, pulling away from the y-axis, whereas vertical shrink, right, is pulling away from the x-axis, right? Or sorry, pulling towards the x-axis. So either way works, all right? Now, if I were to actually graph it, right, I would probably use this function right here. It's a little bit easier to graph. So let's do that. One, two, three, four, five, six. 6. 1, 2, 3, 4, 5, 6. Okay, so 0, 0, up 1 over 1, 0, 0, up 1 over 1. There's my parent function. Okay, so on this one right here, right, I can't just, you know, do a rise over run. First of all, if I ask you what's the vertex, you would say the vertex is 0, -2. Okay, so 0, -2 is right here. Because I can't just, you know, do a rise over 1, run to the 16. A is not an integer, right? It has to be an integer. I'm just going to plug in 1 point. And that easy point to plug in that will give me some nice numbers is 4, okay? Because 4 squared is 16. 16 times 1 over 16 is 1. 1 minus 2 is -1. So 4 comma, you know, -1's right here. That means -4, right? -1 will also be a value, okay? So -1, 2, 3, 4. If you reflect it across the axis of symmetry, right? This is what your graph will look like, right? So this is a, you know, 2 ways of describing this, right? One is saying, hey, this is a vertical shrink, right? I'm pulling it towards the x-axis, or another way of saying it is I'm pulling away from the y-axis. So vertical shrink, horizontal stretch are the same thing. Now, Mrs. Zhu, you know, which way would you want me to describe it on a quiz or test? I probably prefer you do way 1, okay? Because, you know, they give you the B, right? And they kind of want you to make that comparison for the horizontal. But if you wrote way 2, it's not wrong, okay? But preferred way is way 1 because the way it's written. If this was given to you like this right here, then just do way 2, okay? But just to show you both answers work.